Alright everyone, we're coming to you from Delderos 306 today, and this is the solution to exercise 10 from the calorimetry group activity. So the problem's up here, and so we have an acid-base neutralization that we're doing in a beaker. These are pretty exothermic, and in this case this one is very exothermic. The temperature went up from 23.0 to 89.0 degrees Celsius. It's a 435 milliliter solution, and we want to figure out how much energy is given off by this reaction. So we're going to assume that the specific heat of this solution is pretty close to that of water, and it usually is. And the beaker has a heat capacity of 330 joules per Kelvin. Now that's the new thing. Hopefully with the units you could figure out what that meant. That meant for that specific beaker, for every degree it goes up, that requires the input of 333 joules. So the basic background is that the total energy of this reaction, we can say, is equal to the energy pumped into the solution plus the energy put into the beaker. One correction, though, is that the energy given off by the reaction actually the opposite of the energy that is taken up by the beaker in the solution. They are equal and opposite quantities. Energy goes out of the reaction and into the surroundings, which in this case is the solution and the beaker. So all we need now is to figure out what these two quantities are. So let's do the one that we probably know. So the heat or the energy change of the solution is equal to just its mass times its heat capacity times the changing temperature. And we actually have almost all of these things. So we don't know the mass, but we do know the volume. So we told you that there was 435 milliliters of this. Now, we told you that the specific heat capacity is pretty close to that of water. So its density is probably pretty close to that of water too, namely 1 gram per milliliter. And so the heat capacity is going to be 4.184 joules per gram per degree Celsius. And finally, we need to know what the delta T is, and you were given all of those quantities. So that's just 89.0 degrees Celsius minus 23.0 degrees Celsius. And when you put all that together, you get 120,122 joules, or to 3 sig figs, 120 kilojoules. So that is the energy of the solution. The energy change given by the beaker is just going to be its specific heat capacity, 330 joules per Kelvin, times its temperature change, which is the same as the solution. Which is 89 minus 23.0 degrees Celsius. And that gives us, just significant figures, 21.8 kilojoules. So the total energy involved with this reaction, which is just the sum of the energy put into the beaker and the solution, is going to be 120 kilojoules plus the 21.8 kilojoules, which is going to give us 141.8 kilojoules. And that's it.